Welcome to this video about production environments. A production environment is the live system that serves real users with real data. It's where your software application actually runs and operates after development and testing. In this series, we'll explore what makes a production environment different, how to secure it, monitor it, and keep it running reliably. Let's begin our journey to understand this critical part of software development. A production environment fits into the software development lifecycle as the final stage. It comes after design, development, and testing phases. This is where your application meets real users with real data. The production environment serves three important functions. First, it delivers your application to actual users who depend on it. Second, it provides real-world performance insights that help you understand how your system performs under actual usage conditions. Third, it enables continuous improvement by gathering data and feedback from live operations, allowing you to make better decisions for future updates. Production environments have three core characteristics that set them apart. The first is stability. Production systems need to maintain consistent performance with minimal disruptions. Changes are controlled and carefully planned. The second characteristic is security. Production environments require stringent access controls to protect sensitive user data. Only authorized personnel can access the system, and all actions are logged and monitored. The third characteristic is performance. Production systems must be optimized for speed and responsiveness. Users expect fast load times and smooth interactions. All three characteristics work together to create a reliable system that users can trust. Monitoring and observability are critical for production environments. You need to watch four key areas. First, performance metrics like CPU usage, memory consumption, response times, and how much work the system is handling. Second, alerts and notifications. These catch issues immediately and notify your team right away so problems can be fixed quickly. Third, logs and events. These record everything happening in the system, providing a detailed history for troubleshooting and analysis. Fourth, tracing and debugging. This shows the complete path of a request as it moves through different parts of your system, helping identify where problems occur. Together, these monitoring practices give you complete visibility into how your system is performing. Security in production environments operates on four levels. First, access control ensures only the right people can access the system. This means strong authentication methods, role-based permissions so people only access what they need, and audit trails that record every action. Second, data protection uses encryption to secure data both when it's stored and when it travels across networks. Regular backups ensure you can recover from problems, and compliance standards protect against legal and regulatory issues. Third, vulnerability management involves scanning for security weaknesses, applying patches promptly, and detecting threats before they become serious. Fourth, environment separation keeps production completely isolated from development and testing environments with network barriers and firewall rules. This separation prevents testing problems from affecting real users. Backup and disaster recovery are your safety nets in production. Your backup strategy should follow the 3-2-1 rule. This means keeping 3 copies of your data on 2 different types of storage media, with 1 copy stored offsite or in the cloud. Backups should be automated to happen regularly without manual intervention. Multiple backup locations prevent data loss if one storage system fails. Recovery planning defines 2 important terms. Recovery time objective, or RTO, is the maximum time you can afford to be down. Recovery point objective, or RPO, is how much recent data you're willing to lose. Your team should regularly test recovery procedures to ensure they actually work when needed. Having a documented recovery plan ensures everyone knows what to do during a disaster. Production environments must meet 3 types of requirements. First are regulatory requirements. These include data protection laws that govern how you handle personal information, industry-specific regulations, accessibility standards for users with disabilities, and audit requirements from authorities. Second are quality requirements. These include international standards like ISO certifications, service level agreements or SLAs that define your uptime guarantees, performance metrics that measure speed and responsiveness, and testing coverage that ensures code quality. Third are documentation requirements. These include change logs that record what was modified, runbooks and documentation for operators, incident reports for troubleshooting, and access records for security audits. Meeting all three types of requirements ensures your production environment is reliable, legal, and trustworthy. Several tools help you monitor production environments effectively. For metrics collection and visualization, teams use Prometheus and Grafana, which gather performance data and display it on dashboards. For log analysis, the ELK stack or Splunk collects logs from across your system. For application performance, tools like Datadog and New Relic provide deep insights into how your code is performing. Your dashboard should track 4 key performance indicators. Uptime and availability measure how reliably your service is running. Response times and latency show how fast users experience your application. Error rates and exceptions reveal problems occurring in the system. By monitoring these KPIs continuously, you can spot issues before they affect your users and respond quickly to problems. 3 best practices ensure production excellence. First is high availability. This means designing your system with redundant components so if one part fails, backups take over automatically. Load balancing spreads incoming traffic across multiple servers. Failover mechanisms automatically switch to backup systems during problems. Autoscaling adds more resources when demand increases. Second is change management. All changes must be controlled and planned carefully. You need rollback procedures to undo changes if problems occur. Continuous integration and continuous delivery, or CI/CD pipelines, automate testing and deployment. Testing gates ensure only quality code reaches production. Third is performance. Capacity planning ensures you have enough resources for expected traffic. Performance testing identifies problems before users find them. Caching strategies speed up common requests. Continuous optimization keeps your system fast and efficient. Let's summarize the key points about production environments. First, production plays a critical role serving real users with real data, making stability and security absolutely essential. Second, production must be isolated completely from development and test environments with strict controls on who can access it. Third, production requires 24/7 monitoring and alerting so issues are detected immediately and fixed quickly. Fourth, production must prioritize reliability through high availability, redundancy, and disaster recovery plans. Remember, production environments are not just another system. They're the foundation that your users depend on. By implementing the principles we've covered, you'll build a production environment that's secure, reliable, and performs well for your users.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.